Maclaurin series. Maclaurin series is expressed as f of x is equals to f of 0 plus x f prime of 0 plus x squared over 2 factorial f prime prime of 0 plus s cubed over 3 factorial f prime 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 of 0, and let's keep on going like this to x n over n factorial f raised to power n of 0, and keep on going. So the Maclaurin series has this form. So in any given question, we'll be given f of x. So we need to find f of 0, the f prime of 0, f prime prime of 0 to the nth term. Now let's take an example. Example 1. We're going to expand sine x as a series of the ascending power of x. So from the question, f of x is equals to sine x. Now since this is true, we need to find f of 0. So we're going to substitute 0 in place of x. It becomes sine 0, and sine 0 is equals to 0. Next, we need to find f prime of x. Okay, there are two things we need to know. We need to know that if we differentiate sine x with respect to x is equals to cos x, and when we differentiate cos x with respect to x is equals to minus sine x. So while expanding this, we need to put this in mind. Differentiate sine s is cos s. If we differentiate cos s is minus sine x. Now let's go back. Now f prime of s means we need to differentiate sine x, and that gives us cos x. So f prime of 0 is equals to cos 0, and cos 0 is 1. Now let's proceed. F prime of x. We're going to differentiate f prime of x now, which is cos s. If we differentiate cos s, is minus sine x. So f prime of 0. So we took 0 in place of x here. So give us minus sine 0, which is equals to 0, because sine 0 is 0. Now f prime of x, it means we need to differentiate f prime of x. Differentiate this 1. So this is minus, put the minus sign there. If we differentiate sine x is cos x. So we'll take the minus down, differentiate sine x, give us cos x. Hence, f prime of 0 is equals to minus cos 0, which is minus 1. Let's proceed. Now, f, the fourth derivative, this is the fourth derivative of x, is equals to, so we need to differentiate this one here. So we'll take our minus sign down. If we differentiate cos x, it gives us minus sine x. Of course, minus times minus here will give us plus, so become positive. The fourth derivative of f of 0 will be equals to sine 0, which is equals to 0. Now let's proceed now. The fifth derivative of x is equals to, differentiate sine x now, give us cos x. So the fifth derivative with 0 give us cos 0 equals to 1. f vi, there's a sixth derivative of x, is equals to, differentiate cos s give us minus sine x. So the sixth derivative will be equals to minus sine 0 equals to 0. The seventh derivative, if we differentiate minus sine x, this minus, then sine s is cos x. So the seventh derivative is equals to minus cos 0, and that is minus 1. And the list keep on going. If you want to solve more terms, of course you can. We are going to substitute all of this expression into the Maclaurin series. The Maclaurin series has a form f of x is equals to f of 0 plus s f prime of 0 plus x square f prime prime of 0 over 2 factorial plus s cube over 3 factorial f prime 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 of 0 plus 2 xn over n factorial f n derivative of 0, and let's keep on going. So let's proceed. F of x from what we have here is sine x. That is the question. So sine x can be expressed as f of 0. F of 0 is equal to 0. So f of 0 is 0 plus x f prime of 0. Now f prime of 0 is 1. So this is times 1 plus s squared over 2 factorial f prime prime of 0. Now what is f prime prime of 0? F prime prime of 0 is 0. So this is 0 plus s raised to power 3 over 3 factorial f prime 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 of 0. Now f prime 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 of 0 gives us minus 1. So this is bracket minus 1 plus, we know the list continue. After s raised to power 3, of course, the next will be s raised to power 4 over 4 factorial, then the fourth derivative of 0. So what's the fourth derivative of 0? The fourth derivative of 0 is 0. So this is 0 plus s raised to power 5 over 5 factorial, then the fifth derivative of 0. The fifth derivative of 0 equals to 1. So this is 1 plus s raised to power 6 all over 6 factorial, then the sixth derivative. The sixth derivative is 0 plus s raised to power 7 over 7 factorial, then the seventh derivative. Seventh derivative is minus 1. And let's keep on going. Okay, let's simplify this. Sine x is equals to, this is 0. 0 is out of it. X plus, this expression times 0 gives us 0. So we don't need to write it. S squared times 0 is 0, so this is out of it. Now, this is minus 1. Minus 1 times this expression, make it negative. So, it becomes minus s raised to power 3 over 3 factorial. Right, 0 times everything here is out of it, plus s raised to power 5 over 5 factorial. Then 0 times what we have here, it will disappear. 0 times s raised to power 6 over 6 factorial is 0. Then we have plus, okay, yes, minus 1 times s raised to power 7. That will give us bracket minus s raised to power 7 over 7 factorial. So if we simplify this further, we have x plus times minus is minus s raised to power 3 over 3 factorial plus s raised to power 5 over 5 factorial. Then plus times minus is minus s raised to power 7 over 7 factorial. And let's just keep on going. Okay, so we have that sine x is equals to x minus s raised to power 3 over 3 factorial plus s raised to power 5 over 5 factorial minus s raised to power 7 over 7 factorial. So we have expanded it. But from what we have here, we can easily continue the sequence. Now, of course, after s raised to power 7 over 7 factorial, we should know the next one. We observe that the power of x, they are odd numbers, and it is an alternative sequence. Positive, negative, positive, negative. The next term will be positive. Then s raised to power what? 13579 over 357. This is 1 factorial, 3 factorial, 5 factorial, 7 factorial. Obviously, this will be 9 factorial. Then if it's positive, this one will be negative. S raised to power 11 over 11 factorial. Then positive, S raised to power 13 over 13 factorial. And that is how the list keep on going. In example 2, we're going to expand cos x as a series of ascending power of x. So now we're dealing with cos x. So f of x is equals to cos x, and this implies that f of 0 is equals to cos 0 equals to 1. F prime of x is equals to, if we differentiate cos x, is minus sine x. So f prime of 0 is equals to minus sine 0 equals to 0. So f prime prime of 0 is equals to, the minus sign should come down, differentiate sine x is cos x, hence f prime prime of 0 is equals to minus cos 0 equals to minus 1. Now f prime prime prime, that's the third derivative of x. This will give us, take a minus sign down, differentiate cos x is minus sine x, minus times minus is plus. So this gives us f prime 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 of, which is equals to sine 0, which is equals to 0. So f iv, which is the fourth derivative of x, is equals to, differentiate sine s is cos x. So the fourth derivative of 0 will give us cos 0, it is equals to 1. The fifth derivative of x, which is equals to minus sine x. When we differentiate this, we have minus sine x. Hence, the fifth derivative of 0 is equals to minus sine 0, which is equals to 0. The sixth derivative of x, which is equals to, take negative sign down, differentiate sine s is cos x. So the sixth derivative of 0 is equals to minus cos 0 equals to minus 1. The seventh derivative of x is equals to, negative sign should come down. The differentiation of cos x is minus sine x, which become plus sine x. Hence, the seventh derivative of 0 give us sine 0, which equals to 0. Then the eighth derivative of x, which is the differentiation of sine s, which is cos x, gives us the eighth derivative of 0 is equals to cos 0 equals to 1. So let's stop there. You can continue if you want to. So let's substitute this expression into the Maclaurin series. We have that in Maclaurin series, f of x is equals to f of 0 plus xf prime of 0 plus x squared over 2 factorial f prime prime of 0 plus s cubed over 3 factorial f prime 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 of 0 plus, keep on going to xn over n factorial f nth of 0, and the list keep on going. So f of x, according to the question, is cos x, and it's equals to f of 0. So f of 0 is 1 plus s f prime of 0, that is 0, plus x squared over 2 factorial f prime prime of 0 is minus 1 plus s cube over 3 factorial f prime prime of 0 is 0 plus s to the power 4 over 4 factorial of, then the fourth derivative of 0 is 1 plus s to the power 5 over 5 factorial, then the fifth derivative of 0 is 0 plus s to the power 6 over 6 factorial, the sixth derivative is minus 1 plus s to the power 7 over 7 factorial, then the seventh derivative is 0 plus s raised to the power 8 over 8 factorial, then the eighth derivative is 1. So if we simplify this expression, we have that cos x is equals to 1 plus, we have minus 1 here, so minus 1 times s squared is minus x squared over 2 factorial, then 0 times s squared to the power 3 is 0, so we have plus s raised to the power 4 over 4 factorial, then 0 times s to the power 5 is 0, it's out, plus 1 minus 1 here, minus s to the power 6 over 6 factorial, 0 times s to the power 7 is 0, that is out, so plus s raised to the power 8 over 8 factorial, and the list keep on going. So cos x is equals to 1 minus x squared over 2 factorial plus s to the power 4 over 4 factorial minus s to the power 6 over 6 factorial plus s to the power 8 over 8 factorial, and the list keep on going. Okay, so cos x is equals to 1 minus s to the power 2 over 2 factorial plus s to the power 4 over 4 factorial minus s to the power 6 over 6 factorial plus s to the power 8 over 8 factorial, and the list keep on going. So obviously we can write the next terms. The next term will be, if we observe, we have that is the power are even numbers and the sequence is alternating, plus minus plus minus plus. So the next sign obviously will be minus s to the power 10 over 10 factorial plus s raised to the power 12 over 12 factorial minus s to the power 14 over 14 factorial, and keep on going. So this is the Maclaurin's expansion of cos x. Let's move to example 3. In example 3, we're going to look for the expansion of exponential x in ascending power of x using the Maclaurin series. So f of x is equals to the exponent of x. This will be so easy because when we differentiate the exponent of x with respect to x is equals to the exponent of x. So this one is quite easy. Okay, hence f of 0 will be equals to exponent 0 equals to 1. Then f prime of x, if you differentiate this, is also equals to the exponent of x. So f prime of 0 is equals to exponent 0 equals to 1. F prime prime of x, if we differentiate this, we also have the exponent of x. So f prime prime of 0 is equals to exponent 0 equals to 1. F prime 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 of x will still give us the exponent of x. So f prime 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 of 0 equals to exponent 0 is equals to 1. The fourth derivative of x is also the exponent of x. The fourth derivative of 0 is also equals to the exponent of 0 equals to 1. The fifth derivative of x equals to the exponent of x So the fifth derivative of 0 is equals to the exponent of 0 equals to 1. So this implies that all the derivative is equals to 1. Either f of 0, f prime of 0, f prime prime of 0, all derivative are equals to 1. So make it easy for us to just input it into the Maclaurin expansion. Now given the Maclaurin expansion, f of x is equals to f of 0 plus x f prime of 0 plus x squared over 2 factorial f prime prime of 0 plus s raised to power 3 over 3 factorial f prime 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 of 0, and this keep on going to xn over n factorial f the nth term of 0. So f of x here is the exponent of x, and this is equals to, remember that all the derivative of x, whether the first, second, third, or fourth, are equals to 1. So we have 1 plus x times 1 plus s squared over 2 factorial times 1 plus s cubed over 3 factorial times 1 plus s to the power 4 over 4 factorial times 1 plus s to the power 5 over 5 factorial times 1. So the exponent of x is equals to 1 plus x squared over 2 factorial plus s to the power 3 over 3 factorial plus s to the power 4 over 4 factorial plus s to the power 5 over 5 factorial. Now if we want to continue the process, is plus s to the power 6 over 6 factorial plus s to the power 7 over 7 factorial plus s to the power 8 over 8 factorial. This is the expansion of exponent s using the Maclaurin series. If you want to learn more about the Maclaurin series, message me directly on WhatsApp. Meanwhile, subscribe to my channel, like and share this video. I will see you in my next video. Bye.